Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In this video, I'll be going over the configurations for a PID in MapleLogic. I'll be using an ES0808P Maple Modular PLC connected to an IO-SA0400 RTD Module. I will be demonstrating how to control the temperature of a heater using a PID loop. Here is a wiring diagram for connecting a 3-wire RTD sensor to an RTD module and a Maple PLC. So the 3-wire RTD sensor's positive wires are going into A on channel 1 on the RTD module, and then the ground, the white wire, is going into B and the lowercase b for channel 1. And then the digital output from Y10 and the COM here is going into the heater. Now back in MapleLogic, we're going to open a PID control window and create a scan program. So to do that, go to Program, right click, New Program, click Scan here to create the scan program, hit OK. And then another program will create, right click, New Program, and click PID Control under Special Configuration, hit OK. So here is the PID control window. Now you'll probably recognize some of these settings, if not most of them, from the previous video, What is a PID? I would recommend watching that video and reviewing its tutorial. Let's go over the settings up here. So number of loops. One PID loop controls one object, and you can configure up to 32 loops. So you can see here, you can select up to 32 loops. In this sample, I'm going to just choose one. And then loops/scan. This is the number of loops per scan. So I'm going to just select one here. And then start data of PID control. PID initial, I'm going to start just on D0. And then for my calculation, for my actual PID, proportional, integral, and derivative calculation, I'm going to start on D100, and you can see that down here. These start at D100. These are the really important values here. We'll go over the operation type. You have either forward or reverse. So if you were to double click, you can select between forward and backward. Forward is when the process value, or PV, is higher than the set value, or SV. It will increase the manipulation value. Reverse action is when the process value is lower than the set value, and then it will increase the MV. For a heating example, forward would be used and reverse or backward would be used for cooling. Sampling time, this is your sampling interval. This sets up the PID calculation. I have it set to 1 second. And we have proportional gain, integral gain, and derivative gain. So I just mentioned here, that's your PID here. As I explain this, I'm going to be using the term hunting, which is the process in which you are trying to get to the desired target position. You are hunting for that desired condition. For the proportional gain, if the hunting process is taking a while, you want to reduce the proportional gain, or KP. For integral gain, if the value is large, the hunting process is reduced, but the time to stabilize can be prolonged. And derivative gain, or KD. The derivative gain is usually used if you're going to anticipate any signal disruption. So it's typically a low value here that you want to have it set at. It's used for future responses. However, it can also lead to noise amplification, so keeping it low will help avoid this. For the manipulative value, low and high, because we're dealing with a digital output signal, this can be represented as either 0 for the low limit or 16,000 as the high limit. 16,000 means the heater is on, 0 meaning off. You can also change the low to 0 or the high to 1 meaning on. So the manipulative value change rate limit would be the same as the high limit. You want to make sure that these match. And if we're dealing with digital output in our PID, we want to make sure that we have the on-off time enabled, typically at a low value here. On time in a heating example, which is what we're doing, it's the time the heater is turned on to increase the temperature, and off time is a time when the heater is off, allowing the system to cool or stabilize. So just like in the previous video, in the What is a PID video, I went over set value, process value, and manipulation value. Just briefly, set value is your target value. Process value is the temperature from the room being read by an RTD sensor. And the manipulative value is a digital output to the heater. Also, if you are doing a digital output for your PID, you want to make sure that if you click here, make sure that your relay tuning is enabled. So by enabling relay tuning, it will provide a quick and practical way to estimate the PID parameters that you'll need to manually tune for your PID. And then also here, we want to enable self-learning. This will allow the PID to learn the trends that are happening when the heater turns off or on, the amount of time it takes the heater to turn on, and the amount of time it takes the heater to turn off. The PID will learn much quicker if we have the self-learning enabled. So now that I've gone over all the configurations for our PID control window, I'm going to go over our logic on our main scan program, so double click that. And my ladder logic here is really simple. It's just saying that if the process value, which is D101, that is the temperature coming from the RTD sensor, if that temperature is lower than 18 degrees Celsius, the heater will turn on, which here is Y10. And of course, if it goes above 18 degrees Celsius, it will turn the heater off. So now that I've explained everything here for our PID control window as well as our ladder logic, we can now go online. So go to online, link plus download plus monitor. Okay, now we are online and here's our PID window as well as our logic. Now you can see the temperature is actually above my set value, so the heater is off. Now my whole goal here is I want to train my PID to know when to turn the heater on and then turn the heater off. So I'm actually going to be doing an auto tune process. So now I'm going to go to monitor view, and this is just a different view of our PID control window. And so I can actually view the process here. You can see it's set to 0 to 16,000, so 0 being off, 16,000 being on. Because it's digital output, it's just an on and off. And you can see the temperature here, and this is our set value and our manipulative value, which is that digital output. I want to first let the temperature decrease, which will take some time here. And then I'm going to start an auto tuning process, because in order to set my auto tune to the set value, my process value needs to be lower than the set value. Right now it's higher. And then I'm going to train my PID to turn the heater on when it's below that point, and then turn it off when it's above that set value. So now my temperature is below the set value, and you can see that my on-off control output is being initiated here. I'm going to start auto-tuning. I want to see if I can get this PID program to be trained so that it knows when to turn the heater on and turn the heater off. So I'm going to go start auto-tuning. Set that to 18 degrees Celsius or 180, hit OK. So the heater is on because the process value is lower than the set value. It's at 17 degrees and it's going to heat slowly. And now it's gone beyond the set value and it turned the heater off. And of course the temperature will need time to decrease. And then it will eventually drop below that set value again, and then repeat the process. So the temperature decreased. Now it is heating again. And I got above the set value, so it turned off again. Now the temperature needs to decrease. It's going to take some time. And the temperature dropped below that set value. So now we have taught the PID to heat up when it hits a certain point and that amount of time it takes to heat up. and then to cool off when it hits that set point, and then the amount of time it takes to cool off. So it now knows the trend of our heating and cooling process, and it says that loop auto tuning is completed, so you're going to hit yes. And that's the process of using the PID control and also utilizing the auto tuning process in MapleLogic. This is all I'll be covering today. To get more information, please visit the How to Control the Temperature of a Heater using a PID Loop tutorial page on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.